Alright, how are you doing today? Welcome to the video. I will like to talk to you about parametric equations, and the objective for this one is that you should be able to describe a function defined parametrically and eliminate the parameter to convert it to a rectangular function. So let's first talk about what a parametric equation is. So a parametric equation is an equation that we use to define coordinates in the coordinate plane, and most commonly we use a new parameter, and a parameter is just another variable. So we're going to say that x is some function of t and y is some function of t. In this case, f and g here are parametric functions, or functions of another parameter or another variable t. It could be whatever we would like, but in most cases, if we see parametric equations in real life scenarios, we see t used a lot for time. So in most cases, t is time. If we look at some more application problems later on, you'll see that t is referred to as time. So I guess you could think of x and y as being in terms of t or time. In this case, it could be any type of parameter, but sometimes we think a classic example is when we have a x and y plane here, and there's a little bug, a little bug here, a little bug, and the bug is flying, zipping around in the x and y plane, and the bug is traveling in this path at some time t. So after like 2 or 3 seconds, the bug's over here, and then after another few seconds, the bug's here, and then after a few seconds, the bug's here, and we've got this path that this bug's following. Well, he's in the x and y plane, so he's got an x and y, right? He's got an x and y here, and then here he's got an x and y, and here he's got an x and y. So we can locate this bug anywhere on the coordinate plane. That's its coordinates, but they can be represented in terms of time, since this bug is flying around here. And we can also represent the graph in terms of x and y, depending if we can find actually what that graph looks like. So the nice thing about some parametric equations is it allows us to graph things on the coordinate plane that sometimes might not actually be functions of x and y. So maybe the bug decides to go down and then up over and then comes back around and then loops and then goes this way. So we can graph things like this using parametric equations because we separated them. So let's take a look at what we would do with them in terms of the basics, and then later on we'll look at some more advanced stuff that we would use parametric equations for. That'll be on another video though. So let's take a look at some examples. Suppose that we have the following coordinates, x and y, and they're defined parametrically by t squared minus 5 and 2t plus 1. We're going to sketch the graph of this and eliminate the parameter. Eliminating the parameter means that we're going to get rid of t so that we have things in rectangular form. Rectangular is what we normally think of when we're dealing with y in terms of x. Okay, or something like f of x. Okay, that's rectangular form. Right now they're parametric. So we're going to just build a little table here, a table of values. And one thing to note about parametric equations is we have to know that our parameter needs to have some specific intervals. So in this case, I'm going to graph this from the interval t equals -2 to +2. Now, we don't have negative time, so right now we're not really dealing with time. We're just dealing with another variable t. So I'm going to make a table here, -2, -1, 0, 1, 2. And I'm simply going to plug in these values in here for my equations and find out what my x and y value is. So 2 squared is 4, minus 5 is -1. Put it in the y and I get -4 plus 1 is -3. -1 squared is 1 minus 5 is -4. I'll just go ahead and put all these in the x's here. -5, -4, and -1. And I'll put all the y's in here. So again, I'm plugging this into here. So negative 1, negative 2 is going to be negative 1. 0 in here is going to give me positive 1. 1 in here is going to give me 3. And 2 in here is going to give me 5. All right, now these are my coordinates of my points right here for those times. So I'm going to go ahead and plot all of these points and put those together. So negative 1, negative 3, negative 4, negative 1, negative 5, positive 1. Sorry about the little smudge here. Negative 4, positive 3, and negative 1, positive 5. Wow, that's an interesting graph. This may look familiar here. This is a parabola. Let's see if I can draw this parabola with my many skills here. All right, looks like we have a parabola. Now, if I was only drawing it, I don't want the arrows here actually, because I'm only drawing it in this t interval. If I was drawing the whole path, then I would draw the parabola. But you know, we've got a sideways parabola instead of a vertical parabola. So let's go ahead and eliminate the parameters so we can see that this in fact is a sideways parabola. So what we're going to do is we're going to solve for y. Actually, we're going to solve for t here. So we're going to have y minus 1 equals 2t. Divide by 2. So then t is equal to y minus 1 over 2. And I'm going to take all of this and plug it in right there. So I'm going to have x equals y minus 1 over 2 squared minus 5. Bring it over here. Which is going to give me x equals 1/4, because I did 2 squared, 2 right here, 1/4. I'm going to keep the y in the parentheses, y minus 1 squared, minus 5. Now, if you remember back in Algebra 2, this is an equation of a parabola sideways. Now, what's neat about this is that if you're using a TI-84, or actually any graphing calculator that doesn't allow you to graph things that aren't functions, we would not have been able to graph this. Well, in a graphing calculator, it does allow you to draw parametric equations. So you can put this in your calculator as a parametric equation and draw the sideways parabola. Opens up a whole new possibilities with what you can draw in your calculator for parametric equations. So this would be our rectangular equation. It's not really a function. If you wanted to, you can solve for y, and if you did that, you would get y equals plus or minus 2 root x plus 5 plus 1. We add the 5 multiplied by 4 square root, and you get this. So either way is fine. Let's take a look at another example. Parameterize the rectangular function y equals 2. Oh, you know what? Before we do that, let me go back real quick. And I just want to kind of sum this up. So when we graph it, we're going to plug in values of t, find our x and y coordinates, plot those points, connect them, and that's our graph. To eliminate the parameter, we solve for t in one of them, then use substitution to find them in x and y. So that's summarizing that one. Now let's say parameterize, which means just take this function and put it in terms of x and y in terms of t. So we want to have two parametric equations. So this actually is really simple, and it seems like we're cheating, but not really. What we're going to do is we're just going to define x to be t, and if x is t, then y is going to be 2t minus 5, and that's it. We're done. So one of the things that happens, I know you're going, oh, that's pretty cheap, but one of the things that happens if we're trying to make a line segment. So let's see, we're down 5. And then we're up 2 over 1. and we're trying to make a line segment in the, okay, then we would be able to make just the line. In this way, this is a line. So what we would have to do is we'd have to cut this off somehow. In parametric form, we can say t is between 0 and 1. And this automatically cuts this off as a line segment, because I'd put 0 in here, and I'd get 0, -5, and I put 1 in here, and we get 1, -3, and then that's it, and we're stuck. We can't go any further because we identified the t interval as being between 0 and 1. So we're able to take this and make stops. Okay, so maybe sometime if you have a chance, go into your calculator, see if you can make some parametric equations that make some really neat. Maybe you want to do this and maybe make a happy face here, like this. That's a pretty neat happy face you can make with parametric equations. So go ahead and see if you can do that. You can also make that piecewise, but if you really wanted to, you can jazz it up a little bit and try making a jack-o'-lantern, using parametric equations. You can do that. So those are the plenty of things you can do with parametric equations. Here is some practice problem you could try. So take a look at that, see if you can sketch that graph, and that's it for me, folks. The WISC link is down there. Please, if you have any questions, just ask me. I'll reply right back to you. Thanks a lot for joining me. Good day.